Hi, today I'm going to present the paper Microcontrollers, promoting structurally flexible controllers in self-aware computing system. My name is Bento and I'm representing these authors as we can see here. To develop systems with characteristics such as the self-awareness, self-adaptive system approach has been used. One example is the framework Rainbow that is widely used in the literature, due to its characteristics to be used in several domains. However, frameworks like this one are strictly dependent on the target system. Therefore, the reuse of the controller for different target systems may result in a lot of rework. This is due to the monolith characteristics that are configured parametrically according to system needs. There is a need to increase the flexibility and variabilities for different target systems at control level, the controller level in this case, not only in parametrically but also structurally. As an objective of this work, we propose the microcontrollers to develop open and closed control loops. They may be developed and supported by microservers in a granular shape. These microcontrollers fall in a stage like MAPK model. The microcontrollers may share data between themselves using a knowledge that is a component storing the data. For example, target system models and message traffic and so on. Therefore, the microcontroller must be stateless. Being stateless, this increases the reuse of these microcontrollers for different target systems. Finally, the purpose is synthesize controllers that are based on collection of microcontrollers. Give this scenario. A controller may be configured either at design or at runtime. We could define common structures of microcontrollers that are combined at runtime. The responsible of this combination is a meta-controller component that defines which microcontrollers are or are not selected, using adaptation goals involving the target system. Thus, we propose an approach to develop controllers by composing and configuring microcontrollers based on adaptation goals of a specific target system. We can mention some benefits. First, it enables controllers being the locks of change. That means they perform adaptation. And the locks of the change. That means they are themselves adapted. Second, the microcontrollers provide the structural flexibility required to recompose and reconfigure the controller by a meta-controller. So we have a controller that reflects on the target system and the environment, whereas the meta-controller that reflects on the controller. It's enabled the reuse by configuring microcontrollers in a granular shape units that provide generic service to controllers. As a run example, PhoneAdapter is a system that we use in our work. PhoneAdapter was originally proposed by the research community of context-aware adaptive application for exemplifying the definition of adaptation rules that depends on the system context. In our context, we have the Android framework as the target system. The context manager, as we can see in this figure, is responsible for identifying the context of the mobile device using the values of sensors provided the Android framework. So we can have in PhoneAdapter the adaptation manager component that is responsible for controlling the features of Android framework. For example, ringtone volume, setting the effectors according to identified context. Applying our approach, we can have a different picture, as we can see here. Now we have a two-tier architecture. The controller is composed of a set of microcontrollers based on microservices. This controller is managed by a microcontroller. An example of scenario, we can have the need to deal with failures in sensors and effectors. For this, we develop a set of context manager, one for each specific failure. For example, no GPS sensor, no Bluetooth, and so on. We also have a set of adaptation manager, one for each specific failure as well. For example, no audio detected, and so on. Therefore, we have a new microcontroller. The name is Failure Manager, responsible for identifying failures like this that I mentioned. This microcontroller generates data to be consumed by the metacontroller after decision making is performed. For example, if there is a failure in the GPS sensor, the metacontroller has a rule to switch from the microcontroller context manager all sensor to the microcontroller context manager no GPS. Thus, less resources are used during the execution, and in this microcontroller now without the need to get more GPS data, and so on. The same is performed for other sensors and effectors. Some implications that we can mention. The first one is handling changes at runtime. If a GPS sensor fails, when we have the original version of PhoneAdapter, we can deal with generate inconsistent states that impacts the result of the control loop, and more one unnecessary processing and more battery use, for example. On the other hand, when we have the microcontrollers version, a controller is simply selected. Just we can change the microcontroller for a simpler. When we mention about the design time, dealing with the same scenario, failure in this case, the original version, it's necessary perform change for each specific failure and incorporate new requirement in the controller. This means increasing its complexity, so the controller increase its complexity. Microcontroller version, on the other hand, new units of microcontrollers can be included without the need to increase the complexity of the only one component, the controller in this case. So we can have several microcontrollers. In summary, when we compare both versions of the PhoneAdapter, we identify benefits that our approach provides in terms of structural flexibility of the device controllers. Our approach enables the definition of new microcontrollers to compose controllers according to new requirements, without requiring substantial new code changes. Microcontrollers in their variants can be active and deactive at runtime to enable the controller to properly operate in the target system. To promote the design of structural flexibility controllers for self-aware and adaptive system, this paper proposes the synthesis of controllers from a collection of microcontrollers. This we can have a flexible controller structure, letting a continuous deployment dealing with changes at design and runtime. After, the usability can be increased with these microcontrollers. In this case, we can mention these microcontrollers in this case are stateless. So we can have these microcontrollers across several applications. We are aware that the two-tier controllers tends to increase the complexity of the systems. This also may restrict the applicability of the solution. However, there is a range of type systems that this approach may support. For example, systems that require change in their structure depends on their operation state. As future work, we aim to address challenges such as testing the composition of microcontrollers and the result of their behavior in terms, for example, of quantitative data. Another one is develop and specify meta-controllers, whose role is to manage microcontrollers not only in Android environment but also in several applications. Thank you.